Hello boys and girls, welcome to lesson 5-6, the coordinate plane. You see here, this lesson is found on page 395. You can't see the lesson there, sorry. Lesson 6. So we're going to learn about how to use the coordinate plane. And what we mean by the coordinate plane is this. We have the x-axis and the y-axis. Okay, and we have coordinates, and that helps us find locations like the firehouse, the library, and so on. Right in the middle we have 0, 0, 0, x and 0 for y. Now remember, these are positive in this direction, and in this direction the numbers are negative. And on the y-axis, on this direction vertically, it's positive, while in this direction they're negative. So if I were to give you a positive number and a positive number, you would look x and y, and you would be able to find it in quadrant 1. This is quadrant 1, and they go counterclockwise. Quadrant 2, quadrant 3, and quadrant 4. Okay, now we have here, the map shows the layout of a small town. The locations of buildings are described in respect or in relation to the town hall. Each unit on the grid represents one block, like one street block. Describe the location of the barber shop in relation to the town hall. There's the barber shop. It's exactly to the right. So how can we describe it instead of just saying to the right? Because the high school is to the right, and so is the firehouse. Well, we can count the number of blocks. 1, 2, 3, 1, 2, 3, 4, 5. Yeah, it's exactly on 5 blocks. So let me zoom that in. So we have 5 blocks to the right. But what's to the right? Well, let's look at the direction of north, west, south, and east. So we can say it's 5 blocks in the direction of east, so 5 blocks east. The barber shop is 5 blocks east of the town hall. Please copy that down. 2. What building is located 7 blocks east and 5 blocks north of the town? 7 east and 5 north. 7 east. 1, 2, 3, 4, 5, 6, 7, and 5 north. 1, 2, 3, 4, 5. About the firehouses. The firehouse, go ahead and just write that down. Number 3. Violetta is at the library. Describe how many blocks and in what direction she should travel to get to the supermarket. So she's at the library and she's going to the supermarket. Here's our library and there's our supermarket. So from the library she needs to walk 1, 2, 3 south and 1, 2, 3 east. Right? 3 south, 3 east. Southeast. Let's use blue because red was getting hard to see. She must walk 3 blocks south and 3 blocks east. 4. Town Hall and the bank are both located on the same vertical line. Vertical means up and down, boys and girls. Horizontal, left to right. Vertical, horizontal. The number 0 represents the location of Town Hall on the number line. What number represents the location of the bank? So Town Hall and the bank. Town Hall and the bank are on the same vertical line. That's right. And Town Hall is on 0. Okay? 0, 0. 0 on the X and 0 on the Y. But if we start to go up on the Y, 1, 2, 3, 4, we see that the bank is 4 blocks north. So what number represents the location of the bank? Simply 4. Next page. Identify points and order pairs. A coordinate plane is formed when the x-axis and the y-axis intersect at their 0 points. X-axis, y-axis intersect at the 0 point. The axes separate the coordinate plane into 4 regions called quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. So we count counterclockwise, starting with the top right, which is positive, positive. You can use the location on the plane or use the x-coordinates and the y-coordinates to identify the quadrant in which a point is located. So we have our quadrants, and we see that quadrant 1, as I mentioned, is positive, positive. You see it's a positive, positive. So we have 2, 5. Remember, it's x, y. Over here, boys and girls, the way we organize these numbers, it's always x first and then y. X, y, x, y, x, y. So we always move horizontally first and then vertically. So you can see the x-coordinate comes first and then the y. X horizontally, y vertically. So then we have positive, positive. Quadrant 2 is first negative and then positive. We go up, we go across, so negative, positive. Quadrant 3, what is it? Well, we have to move this direction first, so it's negative, and then down negative, right? So this one's negative, negative. You can see it right there. See the numbers? And then quadrant 4, we have to first move towards the positive and then down to the negative. So positive, negative. And you can see, you can see that it says that it's in the positive and that it's quadrant 1. Okay, let's see number 2. For example 2, I want you to remember the coordinate plane that when we go to the right, it's positive, when we go to the left, it's negative, but then also when we go up, it's positive, and down is negative. I think it's easier for you to remember that up is positive and down is negative than it is to remember the right and left. But regardless, identify the point located at negative 1.5, negative 1. Then identify the quadrant in which it is located. Okay, so we have to look again over here where we're being told negative 1.5, right? Negative 1.5, right there, and negative 1. There it is. It's B. But negative and negative, what quadrant is this? Well, this is 1, this is 2, and this is 3. And you can see right there that it's point B and it's quadrant 3. Okay, let's try it. Refer to example 1. Identify the ordered pair that names point A. Okay, point A. So we have to go first horizontally, and we go to a negative 1, and then we count positively half, 1, 1.5. So it's negative 1, 1.5. The way you would write that would be negative 1, comma, 1.5. Okay, do you see that? First the x, then the y. The x was a negative number, and the y we went up to positive. Then identify the quadrant in which it is located. Well, we know this is quadrant 1 and this is quadrant 2. So, quadrant 2. B. Identify the point located at 1, negative 2. So we count 1 horizontally, there's our 1, and then negative 2. 1, 2. Remember, they're counting by half, so each square counts as a half. So we have a half here, and then 1, and then negative 1.5, and then negative 2. So we have positive 1, negative 2. So a positive 1, and then negative 2. And what quadrant is it in? It's located in quadrant 1, 2, 3, 4. Quadrant 4. And that's written as IV. We're also going to work with something called reflection. Making a reflection meaning a mirror, kind of like the same way that a mirror works. And here's a reflection on the coordinate plane. You can use what you know about number lines and opposites to compare locations on the coordinate plane. Consider the number line and coordinate plane below. The number line shows that negative 4 and 4 are opposites. These would be their reflections. So we have 4 on this side and negative 4 on this side. Remember, if I were to draw the y coordinate, it would go right down through the 0 here. That would be, and then I would have the same thing that I have here. So if we were to put them in the coordinate plane, we have our 4 and our 4 here. And this is how we write them as order pair. 4 and 0, because we didn't go up or down on the y. So this is 4x, 1, 2, 3, 4. But did we move on the y? No, we didn't go up or down, so that stays at 0. And over here we moved negative 4 towards the left, 1, 2, 3, 4. But we didn't move up or down, so the y also is 0. And that's how you write the coordinate planes. So the order pairs. The coordinate plane shows that the points negative 4, 0, and 4, 0 are the same distance from the y-axis in opposite directions. From the y-axis in opposite directions. So they are reflected across the y-axis. Notice that the y-coordinate did not change and that the x-coordinates are opposites. So here's an example. Name the ordered pair that is reflected, that is a reflection of -3 and 2 across the x-axis. So we have -3 and 2. We have to go across the x-axis. So you have to pretend that the x-axis is the mirror. Okay, the x-axis. So you're looking here and it's going to reflect on the other side the exact same way. So what needs to change? If we're going to go across the x up and down, that means the y has to change. So we continue to move to -3, +2. We do -3 because we're going across the x-axis. Now we're going to go down to -2. So you see it right there. To reflect across the x-axis, keep the same x-coordinate, -3, and take the opposite of the y-coordinate. The opposite of +2 or +2 is -2. So -2, -2, -3, 2, reflected across the x-axis is located at -3, -2. So remember, we're going to go across the x-axis, so the x-coordinates will stay the same, while the y-coordinates will be the opposites. So, and they want us to name the ordered pair that is a reflection of each point across the x-axis. So I know right now that all of my x will stay the same. There's one, there's my x again, my x-coordinate will stay the same, and my x-coordinate here will stay the same. And I didn't write anything for the y-coordinates. Yeah. I want you to think about it. What is the opposite of -4? Well, we go the other way around and we're going to go up this time, so it'll be 4. What's the opposite of 5? Now we're going to go down to -5. And what is the opposite of -1? Well, now we have to go up to 1. If this doesn't make sense to you, make sure that you ask me in class. Kendall is building a square fence. She places the fence post at the locations indicated on the grid. What is the location of the post that reflects -4, 4 across the y-axis? So we're going to go, we have -4 and +4 on the y-axis. So we have to go across the y-axis for reflection. So we're going to keep the 4 up the same because we're going across the y-axis, so the one that needs to change is the x-axis, right? Because we're jumping across this way. So this is the one that needs to change. So now it's going to be 4, 4, and 4, right? That's 4 and 4. And you can see it right there, 4 and 4. Kendall also placed a fence post at -4, 4, right there. -4, -4, right? -4, -4. What is the location of the post that reflects -4, 4 across the y-axis? Now we're going to go across the y-axis. We still have -4 down, right? We move +4 and then -4 down. So that what changes? This one, right? Because we didn't go this way, we went this way now, but we still went to the same down. So the one that changes is the x, 4, -4. And there you have it. Please save the guided practice for class, but complete the independent practice both front and back of the page. Actually, let's do this again together as another key answer. For those of you that forget to turn the page, please copy these answers down. Fill in the graphic organizer below. Consider the points -3, 2. So we have x and y. -3x and y is 2. Action. Opposite of -3, well, the opposite of -3, boys and girls, is 3. Point -3, 2, reflected across the y-axis. So across the y-axis means we have to change the x-axis because we're going across the y-axis. So we're going to get the opposite of -3 is 3, and then we keep the 2, which is our y-axis. Okay, and then point -2, -3 and -2 reflected across the x-axis. The x-axis means we're going to go across the other way. So the one that's going to change is our y, right? We're going to go across the y-axis down. So now we have -3, -2, and there we have it. Those are your key answers. All right, there. See you in class, everyone.